Have you ever wondered if a cat could be both dead and alive at the same time? Sounds bizarre, doesn't it? Yet, this is the kind of conundrum that quantum physics presents us with. Quantum physics, for those of you who might be new to the term, is a branch of science that dives deep into the world of the smallest particles in the universe. It's a realm where the rules of classical physics that we're all familiar with start to blur, and where things begin to take on a rather strange twist. Take, for instance, the concept of superposition. This idea comes from a thought experiment proposed by Erwin Schrödinger, a pioneer of quantum physics. He proposed a scenario where a cat could be both dead and alive at the same time. Yes, you heard that right. In this hypothetical experiment, a cat is placed in a sealed box with a radioactive atom that has a 50% chance of decaying and killing the cat. Now, according to quantum physics, until we open the box to observe the cat, it exists in a superposition of states. That means it's both dead and alive at the same time, in a kind of twilight zone between life and death. Only when we observe the cat by opening the box does it collapse into one state or the other, either dead or alive. This might sound like something out of a science fiction novel, but it's a cornerstone of quantum theory. It's a demonstration that in the quantum world, a particle can exist in multiple states at once until it's observed. It's a bit like flipping a coin in the air. Until it lands and you look at it, it's both heads and tails at the same time. So, in the quantum realm, reality is a lot more complex than what we're used to in our everyday lives. It's a world where the impossible becomes possible, and where our understanding of reality is continually challenged and reshaped. Can you know both where you are and how fast you're going at the same time? This question may seem odd, but it's at the heart of one of quantum physics' most fascinating principles, known as Heisenberg's uncertainty principle. In the macro world we live in, it seems rather simple to know both where we are and how fast we're going, right? You're in your car, cruising down the highway at 60 miles per hour, and you know you're just passing the exit for the town of Springfield. But when we dive into the quantum world, things aren't quite as straightforward. Let's stick with the car analogy. Imagine you're trying to pinpoint the exact location of a car moving down a highway. The more accurately you want to know its speed, the less accurately you can know its position. Think of it this way. You're focusing on the speedometer, trying to clock the exact speed. Your eyes are glued to that little needle moving around the dial. But as you're doing this, you're not really paying attention to the scenery whizzing by outside. You might have a vague idea of your location, but you can't pinpoint it exactly. Now, apply this to a subatomic particle, like an electron. According to Heisenberg's uncertainty principle, the more precisely we try to measure the position of the electron, the less precisely we can know its speed or momentum, and vice versa. The more accurately we measure its momentum, the less accurately we can know its position. It's not just a limitation of our measurement tools, but a fundamental aspect of nature itself. This might seem strange to us, but it's the norm in the quantum world. It's a world where particles can be in multiple places at once, where they can pop in and out of existence, and where their properties are defined by probabilities, not certainties. The uncertainty principle reminds us that in the quantum world, precise measurements are a bit of a luxury. So the next time you're in your car, cruising down the highway, spare a thought for the humble electron, zipping around its atomic highway with a speed and position that can't be pinned down at the same time. Imagine two twins separated at birth, but still feeling each other's pain. Sounds like science fiction, right? Well, in the world of quantum physics, this isn't far from reality. We're about to dive into the fascinating realm of quantum entanglement. So, what is quantum entanglement? It's a strange phenomenon where particles become intimately linked to such an extent that the state of one particle is immediately connected to the state of the other, regardless of the distance between them. To put it simply, it's as if these particles are deeply in love, their fates intertwined, even when galaxies apart. Let's go back to our analogy of the twins. Imagine if one twin stubs their toe in New York, the other would instantly feel the pain in London. That's how quantum entanglement works, but instead of twins, we're talking about tiny particles. But how does this happen? It all starts when two particles interact in a certain way, creating a special bond. Once bonded, they could travel to the opposite ends of the universe, yet a change in one instantly results in a change in the other. This might sound like magic or the stuff of science fiction, but it's a real tangible phenomenon in the world of quantum physics. It's been tested, proven, and it's shaking up our understanding of how the universe works. It's important to note that this isn't about transmitting information faster than light, which would violate Einstein's special theory of relativity. Instead, it's about a spooky connection that exists between particles, a connection that transcends space and time. Quantum entanglement is mysterious and mind-bending. It challenges our everyday experiences and our classical understanding of how objects should behave. It's a phenomenon that shows us just how wonderfully strange and interconnected our universe is. So next time you think about the twins feeling each other's pain across continents, remember that on a quantum level, something eerily similar is happening all the time. Quantum entanglement, spooky as it seems, is a fundamental part of the quantum universe. So are we all just a mishmash of particles behaving bizarrely? Well, according to quantum physics, we just might be. Let's take a quick trip down memory lane. We've discussed the mind-boggling concept of superposition, where a particle can be in multiple places at once until observed. Then there's the uncertainty principle, which asserts that we can't simultaneously know the exact position and momentum of a particle. Moreover, we've delved into the enigma of quantum entanglement, where particles can be light years apart yet remain instantaneously connected, behaving as a single entity. These concepts, as peculiar as they seem, are the cornerstones of quantum physics. They challenge our understanding of reality and open up a world of possibilities that were previously unthinkable. Quantum physics, with all its oddities, is a testament to the fascinating complexity of our universe. It's a field where questions are plenty and answers are continually evolving.